Good morning, all of you. Today we will discuss about the Mac based on hash function and Mac based on the block cipher. In the previous video lecture, we have discussed about on the what is the Mac and what is the hash function. So today now we will discuss about on the Mac based hash function. In cryptographic approach, the HMAC, this is called the hash uh, hash function on based on the MAC. Is a specific type of message authentication code involving cryptographic hash function and a secret cryptographic key. Or we can say that HMAC algorithm stand for hash or hash based message authentication code. It is a result of work done on developing a MAC derived from cryptographic hash function, and HMAC is a great resistant uh, for cryptanalysis attack, and it uses the hashing concept. HMAC consists basically twin benefits. One is the hashing and the other is the MAC. So it is more secure from the other authentication codes. The hash is issued by the RFC 2104, and in the HMAC or hash function based MAC been made compulsory to implement in the IP security. So basically, we can say that when we use MAC and combined with the hash function, then it is called the HMAC. HMAC is the MAC based on the hash function. Uh, Basically, HMAC used the two passes of the hash function. Number one, the secret key in first used to derive two key, inner and outer. The first pass of the algorithm produced an internal hash derived from the message and the inner key. The second pass produced the final HMAC code derived from the inner hash result and the outer key. So the algorithm provides better immunity against the length extension attacks. An iterative hash function breaks up a message into blocks of fixed size and iterates over them with a compression function. So this is the basic mechanism of the hash function. Now, uh, how to server and the client work using the hash function. HMAC provides the server and the client each with a public and private key. The public key is known, but the private key is known only the specific server and the specific client. The client create a unique HMAC or hash per request to the server, and by combining the request data and hashing that data with a private key, sending it as part of the request, the server receives the request and regenerate its own unique HMAC. The server compares the two HMAC, and if they are equal, the client is trusted and the request is executed. This process is often called a secret handshake. So basically, HMAC is based on the message authentication code and the hash function. Both are the combined, and using the public key and the private key. So now the basic objective of the HMAC. The HMAC is basic. The objective of the HMAC is the HMAC is also is the one way that is the provide generate too easy to generate output from input, but complex the other way to round. Number two, it aims at being less affected by collision than the hash function. HMAC reuse the algorithm such as MD5 and the secure hash algorithm, and check the replace embedded hash function, more secure hash function. And HMAC try to handle the key in the more simple manner. So this is the basic HMAC objectives. After this, we have discussed about the HMAC algorithm and the HMAC structure. The basically HMAC starts with the message M. Uh, this message containing the block of length b bits, and the input is packed to the left the message, and the whole is given an input to hash function, which is give us as a temporary message digest. This is called the md dash. md dash is again append to the an output signature, and whole is applied a hash function, and the result is our final message digest. The example it show the simple structure of the HMAC, where this is the B bits SI, and the S0 is the input, and the MD is the message digest, H is the hash function, the R, and the IV is the initialization vector that is provided in the hash function. So basically this is the hash function. M in this case M is the original function. SI and SO are the input and the output of the signature. Y of I is the ith block in the original message M, where the range is from 1 to L. L is the count of blocks in M, and the K is the secret key used for hashing, and IV is the initial vector. There is some constant, and the B is the number of bits in the block. So this is the simple HMAC structure, or as HMAC construct. This is the input and the output, where K plus XOR with the IPAD, and K plus XOR with the OPAD, where K plus is nothing but the K packed with zeros on the left, so that result is B bits in the length, and where IPAD is or OPAD are the, this is the simple value, respectively B by A times repeatedly. So now we find the MD hash. MD hash is the find out the input or message and find out the hash code, and the MD is equals to final output H equals to S of 0 and MD dash, or MD message digest is equals to S output or hash code of S of I or M. So this is the simple calculation of the S input and the S output. Now we provide some description. The previous algorithm number 1, append here to the left and the K to create the B bits string, because this is called the B plus. For example, if K is length 160 bit and B equals 512, then K will be appended with the 44 zeros. XOR, this is the example. XOR, this is the XOR. XOR with the K plus IPAD to produce B bits S block SI, and append to S M to S of I. This is the process. After this process, apply H to stream generated in step 3. This is used in the step 3. XOR K plus with OPAD to produce the B bit block S. This is the XOR OPAD plus K plus, and this output is provided in the hash code H, and with combined with the initial vector, and after this this is both are combined and provide resulting in the MD dash. This is called the message digest. After this message digest and the output of SO output combined with, and produce the again hash code, and this hash code also combined with the initial vector, and finally produce the message digest. So this is basically a simple algorithm of the hash HMAC algorithm, or hash based MAC algorithm. After this we discuss about some security on MAC. Basically HMAC related to the underlying hash algorithm, if used with a secure hash function, and according to specification, no known practical attacks against the HMAC, means there is no attacks available in the HMAC. In simple way, HMAC can be attacked. Number 1, brute force on the key space, and the attack on the hash function itself. And the birthday attack, although use the key, make this attack more difficult, attack against the compression function. So this is basically the security of the HMAC. After HMAC, mm, we will discuss about the uh, two maps that are based on the block cipher. One is the DAA, this is called the data authentication algorithm, and the other is the cipher-based message authentication code. This is called the CMAC. Now we discuss the DAA. This is the data authentication algorithm. The algorithm can be defined by using the cipher block chaining, CBC, mode of operation of DS with an initialization vector of 0. The CBC and the DS we will discuss in the unit 2. Uh, we have discussed in the unit 2. Um, the data, the data means the message or the record or the file. To be authenticated to groups into the continuous 64-bit block. The block is divided into D1, D2 to Dn. If necessary, the final block is passed padded on the right with the zeros to the full 64-bit block, and using a DS encryption algorithm E and a secret key K, a data authentication code is calculated. Where is the different type of code is calculated? Number one, O1 equals to K and D, means K is the secret key and the D is our data. Other, this is applied to next, and the last is the O of n. O of n E K comma and D of n, means last data D of n, and the join with the last input of the uh, output of the previous stage. The diagram is show that the DAA structure, basically in the DAA structure, there is the kind process one, the T1 is the 64-bit output, then encrypt with the DS algorithm, there is apply the K bits and the produce the O of 1. This O of 1 XOR with the next D of 2, D of 2 is the next block of data, and the last process is the D of n, means the last last block. Suppose we have 4 blocks, then this is n equals to 4, and provide the output of the previous stage working as the input of the this stage and XOR with the this block, and finally produce the output. So this is called the data authentication algorithm. Now we, after this, we will discuss about the cipher based message authentication code. This is called the CMAC. Uh, Basically, CMAC mode of operation for use with the AES and the triple TES. It specified in NIST specially publication 80038B. Uh, it may be used to provide assurance of the authenticity and hence the integrity of the binary data. This mode of operation fixed security deficiency of the CBC MAC. This is the basic CMAC structure. Where is the how? One thing is the how to encrypt and the how to decrypt. So first of all, there is the message. Apply the key, encrypt the message, and this is the working for the output of the next block. This is the message M2, and then this is the process is continuously uh, continuously working on the last message. This is the message length in integer multiple of block size, and this message length is not integer multiple of the block size. There is a two type of CMAC structure. One is the integer length, other is the non-integer length. In the integer length, last block is the M of n, and in the no non-integer, this is the last block is the I 10 minus 2 0. So this is the basically CMAC structure, and the CMAC structure is the cipher-based MAC. This is the basic calculation of the CMAC. This is the C1, C2, and last C1. E of K is the key and 1 is the message. So in the last is the T equals to MSB C of N. The T is the message authentication code, also referred the tag. This is also called the tag. T length is the bit length of the T, and the MSB is the leftmost bits of the bit string X. If the message non-integer multiple of the circle block length, then the final block is padded to the right with a ones and adds many zeros and necessary so that the final block is also of length b. The CMAC operation then processed as before, except that a different n bit key K2 is instead of the K1. So this is the CMAC and some advantage of the CMAC. One can use existing encryption function, means using the AES DSM approach, and the encryption function has properties the resist, pre-image, and the collision attack. And the disadvantage is that algorithms, encryption algorithm can be slower than the hash algorithm. Means there is the DS and the AES approach is slow in compared to hash algorithm. So this is the basic. We have discussed about the MAC based on hash function and the MAC based on the block cipher. Thanks everyone.